All right, so I had to start over. For some reason, things weren't working, or at least I started at this slide. So watch part one of this to see the discussion about the previous slides, and then we'll finish hopefully on this one. So anyway, there's the picture. If you want to do the 95% confidence interval, you are setting up your bell curve so that you've got boundaries that divide the middle 95%, and these are symmetric boundaries. So if this is 0.95, then that means each of these areas in the tails is 0.025, because all of them have to add up to be 1. And then z of 0.025, or I guess what we actually are given here is z of, this is actually z of 0.05 over 2. That's z of alpha over 2. Alpha in this case is 0.05, the total area in the tails, is 1.96 on the right and negative 1.96 on the left. Look in your tables to see that. Okay, so that's how we find a critical value. So let's see them do this. A 95% confidence level corresponds to alpha equals 0.05. So alpha over 2 equals 0.025. That's the area in each tail. And then we'll see the area, this picture in the next slide shows the area in which each of the green shaded tails is 0.025. We find that the z that creates the borders of these areas is 1.96. Okay, so you'll see that in this picture. So that's just the picture we just described. So look through those and see if you can make sense of those things. But this is how you find what are called the critical values that form the z part of our error formula. Now, if you are creating a confidence interval that is common, okay, and by that I mean our common confidence intervals are 90%, 95%, or 99% confident, as you can see here. Then those correspond to those alpha levels, and there are the critical values. You'll use these over and over again for these levels of confidence. This particular table is on the bottom of table A2, and so you can see it and you can have access to it. So you don't have to draw the picture in order to find the critical values. However, if you get some odd confidence interval, so suppose you just want like the 80% confidence interval, then you need to go through the previous example in order to find the critical values. Okay, so that's why we do it. But for most of the time, you'll just use these critical values from this table on the bottom of table A2. All right. The reason we use these is because we need them to find what we call the margin of error, or I've just referred it to as the error, E. Okay. Here's our formula. There's the error formula. You've seen that if you've watched the other videos. And here's how you construct an interval for estimating a population proportion P. Okay. These are all the symbols that we've used, and you'll see them here. Now, there are some requirements before we can do this. The sample has to be random, a simple random sample. We talk about this. The conditions need to be for the binomial distribution. In other words, there are only two categories. Either they have the internet or they don't have the internet. Either they agree with policy A or they disagree with policy A. This particular example, when we're dealing with proportions, we're not dealing with situations where there are three choices. There are only two choices: yes or no. Okay, and then we have to have at least 5 successes and at least 5 failures. So in other words, if everybody is answering yes, it doesn't work. Usually we don't have to worry about those things, but occasionally they'll pop up. Anyway, here's the confidence interval. And you've seen me write this out, and most often I've written it like this: P hat plus or minus your error. But notice your interval is P minus the error. Your lower level, your lower bound of the interval is P hat minus the error. Your upper bound is P hat plus the error, as you can see right here. And there's your formula for error. There's the critical values. And then P hat is given. It's what you've been found from the sample. Q hat, let me write it here one more time. Q hat is 1 minus P hat, 1 minus P hat, and then N is your sample size. Okay. So let's just look. Round off arrows, round the confidence interval for P to 3 significant digits. All right, here's the procedure, but let's just demonstrate an example. We've demonstrated this with several examples, but if you want a listed procedure, there's the procedure given in the slide. So here we go. We've already seen this before. We're dealing with a percentage of people that have Facebook, okay? And we want to find the margin. We want to find the confidence, the 95% confidence interval estimate. And so we'll just go through these. Find the margin of error. Find E that corresponds to the 95% confidence interval. And then we'll use that to find the confidence interval itself, and then we'll reach a conclusion. Okay, can we safely conclude that fewer than 50% of adults have Facebook pages? Okay, assume we're a newspaper reporter. Okay, so let's go through this. Do we meet the requirements? The polling methods that use to gather the data are random. The conditions are met for a binomial experiment. In other words, they have a Facebook page or they do not have a Facebook page. And we have some successes and some failures. Okay, there are at least 5 successes and 5 failures. Okay. We can use technology to do that. I'll try to demonstrate that later. You can follow this through. This is using StatDisk, not a technology we typically use. But here's how it looks if we're just going to do it manually. All right? So the first thing to realize is, since it's a 95% confidence interval, Z sub alpha 2 over 2 is 1.96. P hat is the percent we found from the sample, 43% of our sample. Q hat is 1 minus P hat, there it is. And our sample size was 1487. Plug those into your formula. And you get 0.025. We're going to round that to We're going to round that. After we add and subtract it, we're going to round it to 3 significant digits. But look what you're going to do. You're going to take your interval. Oops, let's try that again. Your interval, the bottom boundary is P hat minus the error, so 0.43 minus the 0.025. Your upper is 0.43 plus the 0.025. And there we go, rounded. We've rounded to 3 significant digits. Okay, so look what our interval ranged from basically 40% to 45%. And this is remember this is a 95% confidence interval. So we're 95% confident that the true proportion of adults that have Facebook pages is between 40 and 45. So look, the question that we were asked is, does it appear that for fewer than 50%? Yeah, because we think it's between 40 and 45%, and that is definitely fewer, and that's below 50%. Okay. So there's the summary. Okay, so analyzing polls. Let's talk about this for a second. Well, you can read that statement on your own. In 95% of the polls, the percentage should differ by no more than 2.5% points in either direction. Where do we get the 2.5? That's our error. Okay? That's our error. So now the interesting thing about this is polls are exactly this. And you'll see this in the news all the time, especially in this upcoming political season, where they'll be saying, okay, we've done a survey and we found that 57% of people are going to vote for Joe Biden. Okay? Plus or minus, and they'll give you a plus or minus. They're giving you the error. Okay? They're giving you the error formula. Now the problem is they're not providing the confidence level. That's the one they've calculated the error using some confidence level, but they don't tell it to you, right? But in our results, we want to do this. We want to give the level of confidence that we use to calculate the error, and we'll also report not only the interval, but we'll report the confidence level, we'll report the sample size, and then of course, again on the news they don't tell you how they sample things, right? But that's going to be important. How did we gather the sample? What method did we use? Okay. And remember this is kind of the nice thing. We a lot of times say, well, you only surveyed 1,000 people, right? In this survey, you only surveyed 1,000 people. But that's not a big deal because, and of course, that's 1,000 out of, however many registered voters there are, 100 million. You're like, well, that's a tiny thing. We don't worry too much about that because that's what these intervals do for us. They account for the fact that we're only using 1,000 people out of the 100 million. Okay, so now there's a couple other formulas that are helpful. If you're given the confidence interval, you can work backwards to p hat just using this formula. The upper limit plus the lower limit divided by 2. P hat will be right in the middle of the confidence interval. You can also find if you're given the confidence interval, you can find the error, upper limit minus lower limit divided by 2. We don't use those very often, but that's important. Okay, so let's look at another example. Well, you can look at these things. So suppose here's a result. Of 71 subjects, 70% were abstinent from smoking at 8 weeks. But they give the 95% confidence level as 58 to 81. Well, what is the sample proportion? What is p hat? Well, just find the value that's exactly halfway between 58 and 81. If that's your interval, then p hat is right in between, and then e is going to be half of this distance from 81 to 58. What's half of that distance? And so you'll see that found out here, or that demonstrated here. P hat is the value that's halfway between 58 and 81. So if you actually want to know what value they got from their sample, well, it turns out from their sample it was 69.695. The error is take the upper limit minus the lower limit divided by 2. Okay. Now here's the last thing we want to talk about. We can work this idea in reverse. In other words, we can say we want our error, right? Because it's an error, and you would like it to be as small as possible. Doesn't that make sense? You want the error to be small. And so you choose the error that you want to be, we want to be within 2% of the correct answer, for instance. Well, if you want a smaller error, then you need to survey more people, okay? Smaller error requires surveying more people. So the question is, how many people do I need to survey? All right? So that's what we're doing. Finding the sample size required to estimate a population proportion. Okay, there's a lot of our notation. I'll let you do that. But what I want to get to is this formula right here. This is the formula. And let's talk about it for just a second. If you know what error you want, and what level of confidence you want, if you know the p hat and the q hat, you can plug those in and that'll tell you how many people you need to survey. Now, we don't often use this. The problem is we don't know p hat and q hat, right? They are unknown. So what we'll often do is use this second version. And in this second version, again, we choose the error. How accurate do you want to be? And what level of confidence do you want? That'll determine z. And then we just use 0.25 in place of these two. And where does that come from? Well, we just assume p hat is 1/2 and q hat is 1/2. In other words, it's a 50-50 split between the yeses and the nos. And so p hat times q hat is 0.25. This is the formula that we often use to determine how many people we need to survey. All right. So in the problems that where they ask you to figure out how many people to survey, use this second formula. All right. Okay, so that should get you started on section 7.1.